Okay, in the case of mechanics, the very useful principle is called as principle of transmissibility. According to this principle, we can shift the force along the line of action of force anywhere, but the 2 points must be rigidly connected. And one force is acting along this line at the certain point, and this one is the line of action of the force. We can shift this force anywhere. The condition is that the point A and B must lie on the same line of action, and secondly, A and B must be rigidly connected. How we can do this? By applying the zero force at point B. So to shift the force, apply the equal force at point B. That is called as zero force. So this is the force F. So this one is also force F, and this one is also zero force. So if you apply the zero force, there is no change in the position. So net force acting still is equals to what? F. A pair of force is called as zero force only if the two forces are equal in magnitude and they are opposite in direction and they have same line of action. Now instead of this, if I consider this force and this force, now is this force, that is this pair is equal in magnitude, opposite in direction? So is it constitute a zero force? So I can add the zero force or I can remove the force from the system. Zero force you can add any time, and zero force you can remove the system at any time. So this zero force is cancelled out, and because of this one, can we shift this force from this point to the new position? So the force is successfully shifted from point A to point B. And now in the system there is no force at point A. The effect of this, whether the system, the force is acting at point A or the force is acting at point B, the net effect remains same. The body still try to tend to move in the same direction as the line of action of force. Now this is a very useful concept. Number of times any complicated figure can be reduced by shifting the force along the line of action of force. But condition is that the point A and B must be rigidly connected. And second thing is that you can't change the line of action of force. So no change in magnitude and the direction of force. The 2 points must lie on the same line and 2 points must be connected rigidly. There must be a rigid connection between the 2 points. There is any car and driver is on this position. Now the vehicle is right now in off condition and you want to give the push. So one way is to push from this side. That is always safer. Second one is that you stand on this side and you pull on this side. But depending upon the driver, you are taking your risk because vehicle can start anytime. So what is the safe position in that case is that you connect yourself from this position and then have a pull in this rope. So is the point number 1 and is the point B, are they rigidly connected now? So you can pull the vehicle, and this is a safety that we are, just an example that we can have a safety using the concept of principle of transmissibility. But forget about this one, and you are here and you are saying that car will not come, because you are not rigidly connected to this one. Or you apply any force to your hand but it is not connected to the car will never come back to you. Agree? Constituted by a couple is normally constituted by number 1, two equal and opposite, two equal and opposite pair of forces. So we must have a pair of force and the two forces are separated by distance d. In that case, they will constitute a couple, and the effect of couple is to translate the rotate the body. That is a pure rotational effect, no translational effect. If only one force will act, it has a translational effect. If two forces act and the two forces are equal in magnitude, opposite in direction, so net force will be equals to 0. But since they are separated by distance d, they will going to produce a couple and the body will try to rotate. So if the body is acted by two forces equal in magnitude, separated by distance d, so what is the net force acting on the system? Is it equal to 0? So what is sigma fx? Sigma fx is 0, because these two forces, if resolved, will cancel each other. Sigma fy equals to 0, and therefore there is no question of translational. But what about the moment? Moment will take place, and is this moment is f multiplied by d. But remember, it's a couple. Because of this one, the body will try to move in a clockwise direction. To understand the effect of rotation sense, you consider any one point anywhere, preferred in the center between the two forces, and just check what is the rotation of this force about this point. Is clockwise or anti-clockwise? Is anti-clockwise, and this force will also rotate anti-clockwise. So the rotation will be anti-clockwise. In our course, we will take anti-clockwise negative and clockwise positive. So this is a case of pure rotation. The couple is called as free vector, whereas moment is a vector. Means the position of the force will matter for the moment vector, whereas the couple is a free vector. You can generate the same couple by applying the force, one at this point. We want anti-clockwise, so one force like this and one force like this, and the distance of separation is equals to d. So this figure and this figure is equivalent figure, no translational but pure rotational. We can introduce the pair of force here also, one force like this, one force like this. You have to remove the initial pair, and now this pair will again rotate this object in a anti-clockwise direction. The meaning is that you can apply the pair of force in any way as you wish, but the distance has to be kept same if the magnitude is same, or otherwise you can apply if you reduce the diameter, then what will happen to the force? This time the force F1, is it greater than F? Is it correct? Now this is the principle used in steering. If we have a smaller vehicle, then we are normally using the lower size of steering wheel size, because we require less torque. But if you see the truck and luxury buses, their steering wheel is large. So to reduce the effect of a driver, we have choice. We can increase the value of d by decreasing the value of f. So naturally, if the value of d will increase, the value of f will decrease, and therefore effort by driver will decrease. At the same time, you can find here the people have number of styles of driving. Somebody is holding vehicle like this, somebody is driving like this, somebody is driving like this one. But all the time it will be our same effect. It is up to you how you hold the steering and in which position you are comfortable. Number of times, this figure is simply shown like this. Now check this figure. Is this value of couple will be equals to F into D? For this figure, is the net force is equals to 0? For this figure, is the net force is equals to 0? And for this figure, is the rotation is purely anti-clockwise, which is the same as the previous case. Is okay? Remember, it's a moment, has nothing to do with the torque. It's pure moment, pure rotation. So let's consider here one point somewhere here, and at this point the force is acting here. Let's say this is the line of action of this force. Let's consider another point here B. Now this point B is not lying on the same previous line of action. The objective is to shift this force from this point to this point. That can be done with the help of couple. Now again in the mechanics we can take the concept of zero force. So what I do is that where I want to apply the force, I will apply one pair of force, which is the same as the previous one. That is, this force is F and this force is F, and this total force is zero force. So it means that this system is same as this system. That is pure translational system. Now as far we have just discussed the idea of the couple, now see this force and this force. Are these two forces constitute a couple? Because these are two parallel forces, and let's say that this is the perpendicular distance between them is d. So this pair of force constitute a couple, and the magnitude of this couple is force multiplied by distance, and the sense of this couple, so you can take any point here, is this sense is the clockwise sense. Correct? As seen just now, if we have two forces and they make a couple, can we show the couple by this way? Then if you show the couple like this, then you no need to show the forces again, because this is equivalent figure. So this is a couple. What left is the one force which was acting at point B. Now this force is not present here because this force F and this force F are replaced by one couple, and the couple sense is clockwise. Magnitude of couple is Fd, and the magnitude of this force is remains same. So what we have done is that we have successfully shifted the force from point A to point B. Is that correct? एक बार चेक करेंगे मेरे साथ. If you want to shift the force at B, you apply one force equals to the same magnitude F, and this pair is called as zero force. And if you observe this force and this force, so these two forces are equal in magnitude, opposite in direction, separated by certain distance d. So this pair will make a couple, and the magnitude of this couple is F into d, and the sense of this couple is clockwise if you consider any one point somewhere here in between the two line of action. So you can replace these two forces by one couple like this, and therefore the final force F is present here. This force and this force are replaced by a couple. So what you observe from the first figure and second figure, the force has been shifted successfully from point A to point B, and the both points are lying on different lines. Whereas the principle of transmissibility says that you can shift the force at A to some point C somewhere here. In that case, the magnitude of force will remain same. That is the principle of transmissibility. Permission of shifting is only permitted along the line of action. Whereas this principle, using a couple, we can shift the force anywhere as you wish. But whenever the force is shifted, is the magnitude of the force will change? Is the direction of force will change? No. No change in magnitude, no change in direction. But is the additional couple is produced? So there are two rules when you are shifting the point from point A to point B. So rule number 1 is magnitude and direction of the force remain same. But rule number 2 says that if the line of action is changed, then the additional couple is produced. So whatever the additional couple is produced, you find that magnitude of that couple using the equation that moment of the force about new position. So what is the new position is B. And you can do this from the original figure itself. Is the moment of this force F about B is a clockwise. And what is the magnitude of this one? Is it F multiplied by D? So let's say this is the initial figure with point A and point B. I have marked 2 points. I have one force at F. So as per the rule number 1, apply one force at point B, which has no change in magnitude and direction. And from original figure, calculate the moment of this force about point B and show this moment at point B. And this one is, remember, couple. So you can shift the position anywhere as you wish. And the magnitude of this couple is the force, moment of force about new position. That equals to force multiplied by distance D. Remember, this value you have to calculate from the original figure. So as far as the force system is considered, we normally classify as a coplanar and non-coplanar force system. And in that one, we'll classify as a collinear, concurrent and non-concurrent. What is collinear? The line of action is same. What is concurrent? If all the forces will pass through one point. And what is non-concurrent? If the number of forces will intersect at number of points of intersection are more than one. So if there is no intersection, it is called as collinear. If there is one intersection, it is called as concurrent. And if there are more than one intersection, it is called as non-concurrent. The discussion that is applied for coplanar is also applicable for three-dimensional, that is non-coplanar force system. Suppose we have a body like this and we have a forces acting like this. One force like this, one force like this, one force like this, another force like this. So are these forces will going to intersect or will not intersect? Will not intersect. So number of intersection for this one is n equals to 0. Suppose we have one force like this, one force like this, another force going this way, one force this way and one force this way. Now is the number of intersection of all line of action is equals to 1. So this one is called as concurrent force system. We have one force going this way, we have another force going this way. So this is one intersection. Is it correct? So intersection number 1. But if we have another force going this way, so we have now two intersections. This is number 2 and this is number 3. If I introduce one more force, it can go this way. So I have two more intersections. One is this, one is this. So if the number of intersections are greater than 1, that is called as non-concurrent. Equal to 1, concurrent. And n equal to 0, it's a coplanar. So what is the effect of coplanar? Coplanar is a pure translational depending upon the direction of force. Then concurrent effect is pure translational, but the net force you have to first find out and the body will move in the same direction. And what is the effect of non-concurrent? Your body will translate as well as your body will rotate. So conditions of equilibrium for this, the net force acting must equals to 0 and the sum of moment must equals to 0. These are the conditions of equilibrium. And then you can make this value sigma fx0, sigma fy0, sigma fz0, sigma mx0, sigma my0, sigma mz0. So you can generate 6 equations. Whereas far as concurrent is considered, there is no translational. So we left with only one equation, that is sigma f equals to 0. So at the most you can generate 3 equations, sigma fx0, sigma fy0 and sigma fz0. For this one, the force is acting only one direction. If I say this direction is fx, so only one condition is required, that is sigma fx equals to 0. If I say this is the direction x, you no need to balance along y, you no need to balance along z also. But this time you have to balance along x, y, z. So only one condition, 3 conditions, and we required 6 conditions. So this is how we can develop the equations in mechanics, and once we develop the equation for concurrent, non-concurrent or collinear, we can successfully solve any problem. The important concept after this is free body diagram. The very first force that normally exists in the case of flexible elements like rope, wires, string, and is called as tension force. This tension is normally called as internal force. This is normally possible in the case of flexible element. And in mechanics, you are given the full permission to cut this force anytime. You can cut only internal forces. No permission for external forces. Remember this. But if we have a bar or a rod, so bar or rod can be either in tension or either in compression. Here I am going to show you the compression effect. So for compression, the force will act outward. And again, mechanics, you have full permission to cancel this. So zero force member will be standard represented like this. This is called as zero force. These are the dummy members normally used in the case of truss, because if any adjacent member will fail, then the load is taken by this member. But up to that time, there is no force in this member. So additional members are always provided for rigid structure. So contact force or normal reaction. First of all, what is contact? Whenever two body will come in contact, we are called a contact force. And secondly, it is called as normal reaction because it always act on a plane, the plane which is at contact perpendicular to that. So that is why it is called as normal reaction, and it is based on Newton's third law. Action reactions are always equal and opposite. So we have a cylinder here and is rested upon two surfaces. One makes an angle of 30, another makes an angle of 60. So the force will pass. Force is always perpendicular to this plane and will pass through center. This force is also perpendicular and will pass through center. That is called as normal reaction. This angle is always 90. This angle is always 90 because the name is normal reaction. That is why this force or this reaction Na will make an angle of 60 degree. Whereas this reaction will make an angle of 30 degree. This is 30, this is 60, and this one is 90. Sum is always equals to 180. Now this time it is called as ground reaction. In this figure I have given one hollow cylindrical shell which is open on the top, and one cylinder is here on the bottom, and this cylinder is in contact with the larger cylinder. So now how many contact points we have? So we have a normal reaction on this plane. Let's call A. One normal reaction here is equals to B. One normal reaction here is equals to C. This one, ABC, are same as this one. So when you want to show this, you can show like this. So this is Na, is always perpendicular to plane of contact. One is this, that equals to NB, and one is this, that equal to NC. The third contact, the fourth contact is here. But right now, you can't visualize this contact. You can't see that force because the body is in contact. So right now the ability for this figure is this one only, plus two additional weight W1 and weight W2. Now if you are interested to show and want to know the contact at here, so first of all you have to find out this one is C1 center, this one is C2. If you join this C1 and C2 like this, then is this contact plane, this contact, is it perpendicular to this plane? Correct? This is a tangent plane, and there is only one tangent plane between the two cylinders. Now this plane is same concept as this one, but right now I am unable to show the reaction because this will push it downward. So it will give the equal and opposite reaction on the Newton's third law. If you want to visualize this force, then you have to separate it first. Then only you can visualize this. First of all, you must know what is the angle constructed by this. The procedure is known to you. That is, this one has a radius equals to r1 up to this point. This has a radius equals to r2. And suppose this one is the width. Then what is the distance between this one? Is this distance is b minus r1 minus r2. So if we draw the triangle like this, then is this distance is b minus r1 minus r2. And this angle is theta. This one is c1 and this one is c2. Is this distance from D point to c1 is r1, and from c2 to D is it equals to r2? So comparatively you can calculate the angle now using cos theta. So what is cos theta? B minus r1 minus r2 upon r1 plus r2. Once that angle is known, we can shift this figure slightly away along the same line of action like this. So this is the line of action and this plane is somewhere here. Now what will this top cylinder will do? The top cylinder will show here. So what exactly we are doing in the FBD, we are showing the presence of this body over this body, but at the same time we are hiding the body. That is what called as free body diagram. Means the body is isolated from the rest of the world, but you can visualize the its effect. So you can't see the cylinder C2 when you analyze this, but can you see the effect of that one? This is what exactly called as free body diagram. And according to Newton's third law, there is equal and opposite reaction. So this one is ND. That's fine. So we must answer why we are introducing the FBD. Now check this figure. Wait a minute. Check this figure. How many unknown? One is NA, one is NB, and one is NC. So we have three unknowns. Is it correct? So problem can be solved here itself. Remember, there is no fourth unknown in this figure because the body is in contact. So two equal reactions will cancel each other. But we can very well solve this problem. Very well solve this problem. No question about this one, because this is a non-concurrent force system. This is one interaction, this is second interaction. If the number of intersections are more than one, so how many governing equation we have? This is two-dimensional. So we have sigma fx equals to 0, sigma fy equals to 0, sigma fz. There is no question of sigma fz, and only one equation is available in the moment, that is moment about z-axis is 0. So in a plane motion, we have three controlling equations: sigma fx 0, sigma fy 0, and moment 0. So you apply this equation and you are very well able to solve this. But suppose there is one more cylinder here. So is the additional reaction will come here in the same problem. I will not show this reaction, but now the number of unknowns are how much? Let's say this equals to NE. So number of unknowns become 4. Is that correct? One is NA, second is NB, one is NC, and the fourth one is NE. Now you have limited equation. That is not going to change. So what you will say? I have 4 unknowns and 3 equation. Problem cannot be solved. So that is why FBD is introduced. So basically FBD is introduced. You can draw the different FBD and you can increase the number of equation. But remember, each set of equation is same. Sigma fx 0, sigma fy 0, and moment 0. But you can repeatedly use this equation for different figures. So this is the idea about the free body diagram. And that's why the free body diagram is always used in the mechanics.